In this video, we're going to solve a problem which appeared in JEE Advanced 2019. So first, try to understand the problem. Here, we are having a give matrix M, and we have given that we have to rewrite it in the form of alpha I and beta M inverse, where alpha and beta are the function of theta. I is a 2 cross 2 identity matrix. Now, first we have to find out the alpha and beta value or a function, and then we have to find the minimum value which is given as alpha star and beta star. So let's go ahead and solve this problem again in step by step. Let's go ahead. So here, right, first we notice that we have to rewrite that matrix M in the given form, right, that M is equal to alpha theta into I plus beta theta into M inverse. What is I here? I is a identity matrix order 2 cross 2, and M inverse is the inverse of the matrix. So here obviously we understand that if we able to find the M inverse, right, we can equate the matrix, right? So our next step after finding the M inverse, equate the matrix equation and find out what is alpha and what is beta as a function of theta. And after obtain alpha theta and b theta, we have to find alpha star and beta star, which are the minimum value of alpha theta and b theta in the interval 0 to 2 pi. 0 is closed, 2 pi in that side it's open, right? It's semi-closed, semi-open interval. That's it. So first our aim is to understand how we calculate a inverse of a 2 cross 2 matrix. That is a very easy way method to calculate that inverse of a 2 cross 2 matrix. So first we go ahead and discuss that theory basic, right? So let's go ahead. So here we consider a 2 cross 2 matrix which is given by ABCD. Now we know that, right, that A inverse is equal to 1 by determinant A into adjoint A. 1 by determinant that DTA is the determinant of the matrix and adjoint A is the adjoint matrix. What is adjoint matrix? Is the transpose of the cofactor matrix. So now we need to find out the cofactor matrix. To find the cofactor matrix, right, we need to find out the first element. So if the cofactor matrix is C, right, so we need to find out that what is C11. To find the C11, we have to eliminate, right, or delete the first row, first column to get the first element C11. Here it is D. Then we need to find out, right, the second element. So do so, we have to eliminate the first row and the second column, which gives me C. Then we eliminate the second row, first column to get the C1 row 1 and 2. And then we eliminate the second row, second column to get the C22, which is A. So these we calculated all are minors. Now these minors need to be converted to cofactor. How we do that? Always remember that to find out the cofactor, it will be the, if it is C11 or Cij, we have to multiply the minor by -1 whole to the power I plus j. But there is a shortcut. Here, if we go ahead, we can see that I plus j. So if it is even, it is plus, or it is -1. So that's why, right, we can go say that this, when you write down the sign of this minors, right, or to get the cofactor, we will put the plus minus sign alternatively. So let's go ahead and write alternatively. So the first D will be plus sign always, then alternative. So plus, then minus, then plus, then minus. Okay, follow the order. Now if we go clockwise, anti-clockwise, boom, go ahead in the bottom direction, right direction, whatever, it will be always alternative direction, but follow that pattern. Okay, that's it. So this transpose will gives us the adjoint of a matrix. Now observe the matrix A and observe the matrix adjoint A. Notice that for a 2 cross 2 matrix, right, the diagonal elements, right, are interchanged, and the non-diagonal elements BC will be multiplied by a minus sign. So that's it. So therefore we can say that the diagonal elements will interchange and non-diagonal element will have a minus multiplication, or we have to interchange their sign. And obviously the determinant A, that's well known, AD minus BC. So therefore A inverse is equal to 1 by AD minus BC into adjoint A. Okay, That's it. So you can easily obtain the inverse of any 2 cross 2 matrix following this theory. Let's go ahead. So here now we consider the matrix now, and then the adjoint matrix, right, will be given by, right, what should we do? We have to interchange the diagonal element, and the non-diagonal element we have to multiply it by -1. So therefore we obtain the adjoint m. We recall that, right, what is A inverse, right? So we need that M inverse is 1 by determinant of m into adjoint m. So therefore we get M inverse in a straightforward way, right? So you obtain the M inverse. So where determinant of m is equal to that sine 4 cos 4 and all. So we have to find the determinant of m, right? So let's calculate the determinant of m. So we do that by doing that cross multiplication. So therefore cos 4 sine 4 minus 1 plus cos square into minus 1 plus sine square theta. Okay, that's it. So if we go ahead, right, we calculate, right, the determinant of m, right? Now let's go ahead and calculate this, right? So if we do the cross multiplication, okay, and try to do the simplification step by step, we get that it will be equal to sine 4 cos 4 1 plus sine square cos square theta, sine square theta, and cos square theta. For any angle of theta, we know that sine square theta plus cos square theta is equal to 1. So that's why we can easily simplify the determinant of m is equal to sine 4 cos 4 plus sine square cos square plus 2. That's it. So we already calculate that in a very trigonometric fashion, right? So let's go ahead. So here we just write down in the place of determinant, and we forget about whatever we calculated up to now. So now we see that we already got our M inverse, right? That's it. Now our next job is to calculate, right, the values, right? So let's go ahead and calculate the M inverse, right? So we can easily put that determinant of M and all that stuff, we get that. But we should not continue in that manner, right? Because then the calculation became bigger. So for further calculation, we have considered that determinant M as it is. Let's go ahead. Now let's consider the matrix equation. So here we know that M is equal to alpha theta into I, where I is the identity matrix, beta theta plus M inverse. So we consider that all the values, right, that already seen in the screen. Okay. Now for calculation purpose, we consider that beta dash is equal to beta by determinant of M. Now, if we consider that, then we rewrite the given matrix equation. How? Because we added the matrix, right, by element wise, right? So notice that here, right, we are actually talking about that these two matrices are of same order, right? So alpha plus beta dash into cos 4 theta, 0. So gone, beta dash into 1 plus sine square theta. So element wise we added and we get the matrix, right? That's it. Now see that, right? We have to equate them. Now see that if we apply the equality of the matrix operation, these two matrices are having the same order. So therefore, we can apply the equality of matrices. So here sine 4 must be equal to the first term. The 1 plus sine square theta must be equal to beta dash onto that, and so on and so forth, right? So if we go ahead, right, we get by element wise equation, right? We get 4 different equations, right? That's it. So therefore, we get a relation between that sine, cos, and all that stuff, right? So let's play with this equation now, right? Let's go ahead, right? So if I equate them, right, we get, right, this 4 equation, and where beta dash is beta by determinant of M, right? So we renamed it as equation number 1, 2, 3, 4. Now notice that from the equation 2 and 3, 1 plus sine square will be cancelled and 1 plus cos square is cancelled from both sides. So therefore, we can say that beta dash will be equal to -1. What is beta dash? We see that it is beta by determinant of M. So therefore, beta is equal to minus determinant of M, right? That's it. That's the first observation. Now we notice that, right, if we go ahead, right, we see that, right, what is beta? So beta is equal to, right, that determinant. So determinant of M is already calculated. So therefore, we understand that, right, this sine 4 cos 4 and all that stuff, right, is equal to, right, that the value of beta, right? So I just go ahead. Now notice that beta dash we computed as -1. So if I substitute the -1 value in the relation number 1 or relation number 4, so therefore we get that, right, that the value of alpha. So what is the value of alpha? Alpha is equal to sine 4 plus cos 4. So therefore we obtain that alpha and beta or the is a function of theta, right? So now we can find out, right, the minimum value. So let's go ahead and take only the alpha and beta function, right? That's it. Now see that, concentrate on alpha. So you can say that alpha can be written as completing the square form, right? So we add 2 times of sine square cos square theta, we added it and we subtracted it. So the two line became the identical, right? That's it. Now see that the first three terms will be sine square plus cos square theta whole square minus 1 by 2, right? That sine theta cos theta whole square. Why I write 1 by 2? Because see that, right, if I insert that, this is we already known as a formula. What's the formula? Because we know that 2 sine theta cos theta is sine 2 theta, and for any values of theta, sine square theta plus cos square theta is equal to 1. So therefore it is simplified as 1 minus sine square 1 by 2 sine square 2 theta. Now see that, notice that theta lies between 0 to 2 pi, as theta lies between 0 to 2 pi. So therefore we'll say that, right, that whatever the case, right, alpha theta will attain its minimum value when sine square 2 theta will attain its maximum value. Sine square 2 theta will attain its maximum value in 0 to 2 pi is obviously 1, because we know that for any angle of theta, sine theta lies between -1 to +1. So therefore alpha will attain its minimum value when sine square 2 theta is equal to +1, and hence minimum of alpha theta is half, and therefore alpha star is equal to half. So you obtain the alpha star. Now our job is to go ahead in the similar way to find the beta star or the minimum values of beta. So obtain that, right? First we rewrite it using the similar way of completing the square. So first term is sine square theta cos square theta whole square is 2 times of sine square theta plus cos square theta. We multiplied by half so that this term became equal, and then, right, we add 1 plus half whole square minus 2 into 1 plus half whole square. So here this 1 by 4 term get cancelled, so these two lines became identical. Now here also notice that the first three term will be equivalent to, right, that sine square theta cos square theta plus half whole square plus 7 by 4. Why? 2 minus 1 by 4, so 7 by 4. Now let's go ahead. Now see that we already know that sine square theta cos square theta, so we multiplied by 4 by denominator and numerator, and we know that sine 2 theta is 2 sine theta cos theta. So if I use that, right, we rewrite that beta theta will be in the form of, right, sine square 2 theta by 4 plus 1 by 2 whole square and 7 by 4. Also notice that now this beta theta will attain its minimum value, right, when that function, right, sine square 2 theta attains its maximum value. Why so? Because see that it is minus sign, so forget about it. So minus means that if we are talking about this beta minimum, right, the value inside the bracket should be maximum. It is maximum when sine square 2 theta is maximum. So therefore we'll say that maximum value of sine square 2 theta is already 1. We already discussed in the previous step. So therefore we can find the beta will be equal to 1 by 4 plus 1 by 2 whole square and 7 by 4. So if we calculate, we get it as minus 37 by 16. So this is the value of beta star. So now we obtained alpha star and beta star. So therefore, if we add them together, we get that alpha star and beta star, which is minus 29 divided by 16. And hence, option D for this problem is the correct solution. And that's it. Hope you understood the problem. Thank you.